So for those of you who don't know me, my name's Riya, and I'm a junior here. And today I'm going to be presenting my ASI project from 2 years ago called How Square is a Square. So I'm just going to start off with a basic question. What makes a square a square? Does anyone know? Okay, whatever, I'll just answer. A square is basically like parallel lines, like 90-degree angles, like that kind of thing. But now I'm going to ask a slightly harder question. Which one is more square, a triangle or a circle? Does anyone have an idea?
Circle.
Yeah. Okay, so like intuitively, yeah, right, circle, right. So if we take a look, if we put a square on top of both of these shapes, the circle more closely resembles the square, and the triangle is kind of further away. And so my project is exploring all about this and seeing how square objects are and basically assigning them a value of how square different polygons are. So like, I'm just gonna create an algorithm that calculates the squarality of a polygon, which is basically how square it is on a value from 0 to 1. So why does this even matter? Because this is kind of just random, but basically this is a shape detection algorithm, which is useful in a lot of cases. For example, in factories, you could, the factory could see how square their products are, and then if it's like 97% square, then they can use it as a product, and it's a use of error management. But another one that I think is more interesting is gerrymandered districts. So if you don't know what gerrymandering is, it's like basically where they create the voting regions, which are like unfair because like look how weird they look. And so to make it more fair, they would rather just make them more square or more like normal. So you could run it under my algorithm to see if it's square. Yeah. So one other thing is that you actually can't use AI for this because these are discovered by law and they have to be proven and justified using some sort of means. And since AI is a black box, it can't provide that kind of justification. So I created an algorithm which can be used in cases like this. And it also just gives us an insight onto how AI actually works. Yeah, so there's a few existing algorithms that are in place right now for shape detection. So the first one is called path-based, where it's basically counting in n moves, how can you get a shape into a square? So it's like rotating is one move, and then dilating is another move, removing a point, that kind of thing. But it's not very accurate because a very stretched out shape would have the same score as a shrunken shape. So like not very accurate, but another one is area-based, which is basically comparing the area of the polygon versus the square that best fits. But then again, this is also not very accurate because you can just change the best fit square to be the same area, and then everything will have 100% accuracy. So that's also not great. And then the last one is distance-based, which is currently the best one that's used. And it's basically, you map it to a best fit square, and then you calculate the average distance traveled by each point to the square. But obviously that also has its own problems because you can just change the square to be dilated or shrunken, and I think that that should be part of the calculation for how square it is because dilating and shrinking a shape is like costly. So in my approach, I decided to combine the area and the distance formulas and create like one big combined formula. So basically, mine takes something called the area cost and the distance cost. The area cost is just the smaller area over the larger area of the polygon and the square. And the distance cost is the average distance traveled by each point and with respect to this like square side length. That way everything is like normalized and it'll be from 0 to 1. So yeah, and it takes the minimum of them both so that it will find the maximum of it'll find the maximum of both of them. Yeah. So then I created an algorithm to see how this actually works. Yeah. So I created an algorithm using JavaScript, and it's actually available at squaretest.app if you guys want to try it out. But basically you can generate any kind of shape and it'll give you the squarality score and how it actually calculated it. And using this, I was able to find a few observations based on the results. So the first one is it meets something I call the reasonableness test, which is basically, does it know what a human would know? So I tested out shapes like squares, rectangles, rhombuses, parallelograms, and it all matched when I polled with people. It matched the people's thoughts, so it's like intuitively correct. Also, with regular polygons, as you increase the n, so as there's more sides on the regular polygon, it gets more and more square. And like as for that one over there, it's 100 gone, and that's like pretty close resembling to a circle, and that's about 95% square. So that's estimation for how square a circle is, if you wanted to know. And also the last one, which I think is cool, is that the algorithm is actually reversible. So you can completely reverse this and find shapes near a desired squarality score. And actually put that into my algorithm so you can give it a desired score and a tolerance, and it'll find multiple shapes with that score in mind. And it does this just by shrinking or dilating the shape or trying to make the sides more even, and like, yeah. Okay, so like what's next for this project? So it's, right now I only did it for squares, that's why it's called how square is a square, but you can obviously extend this to other polygons and other shapes. So you can say like how close is it to a triangle, how close is it to a rhombus, and different things like that. You can also increase it to 3D, so you could be like how cube is this shape, or something like that. There's a lot of different applications, and right now it's only for polygons, but this can also easily be added on to curved objects like circles with the use of like calculus to calculate the distance each point travels. But when I did this project, I didn't know calculus yet, so that's why I didn't do that. But it's a very cool application that someone should look into. Yeah, great. Any questions? How do I do this?
How did you come up with the idea for this project?
Great question, Allie. Oh, she asked, how did I come up with the idea for this project? Basically, I was in math class and I was looking at shapes and I was just like, I think we were trying to prove that something was a square in like geometry class. And I was just like, well, why is it square? And then I was looking at a bunch of different shapes and I was like, wow, I should make an algorithm for this. And that's how I got here. It was really just like, I thought of something cool and I wanted to make it. Any other questions?
How long did it take to make the algorithm?
Can you repeat it? How long did it take to make the algorithm? Real answer, like 2 days. But I had to make an app for it and I had to like test and code stuff. So it took me a little bit over a month to make this. But yeah, but like everything can be done super fast in math. So yeah.
There's one back here.
Can the algorithm be like easily adapted to other shapes like circles? Or-
Yeah, the algorithm can be easily adapted. Right now, it just maps each point onto the square. So you can easily change it by just mapping it onto a circle or mapping it onto a triangle. If you did something like a circle though, since it has curved edges, you have to use calculus in order to find how much each point must travel, which is a little bit more complicated, but it's just as simple, so you could do it.
What like parameters would you use if it was a three-dimensional thing instead of area and distance?
Yeah, so distance would stay the same because each point traveling would still have a distance, but instead of area, you just use volume. So yeah, it's pretty similar. You literally just add a z-coordinate and then everything, all the formulas still work the same way because distance and volume have similar formulas. So yeah.
Can you please explain your experience in ASI for those who are looking to take it?
Okay, wait, for this project, I wasn't actually in the class because I was a freshman, but I just like joined the class so that Mr. Dressen could take me to the science fair. But I'm in ASI this year, and I don't know, we just like research all the time, we present our findings, you get to hear a lot about other people's research, and you get to hear like how they're thinking of things, which is really cool. I would highly recommend the class. I don't know, I haven't been in the class for that long, so yeah.
You mentioned that it was an app. Have you thought about like adding a camera function?
That's possible, yeah, you could add a camera function. You would just use it like an AR detection program and it would map it into a polygon. So that's like how the factories would use it. They would use a camera to like look at their products and they would apply the algorithm based on how the products are like shaped. Great.
Is the app in the App Store?
It's a website, so it's at squaretest.app if you guys want to see it.
You said squaretext.app?
Squaretest.app.
Oh.
Yeah, Square. Oh. Yeah, squaretest.app. You can go see it and you can try it out for yourself if you want.
Are there like any real-world application other than the one that you already mentioned?
The biggest application I think is for factories, but obviously that can be done with AI. The like biggest reason I did this project is that when you create more algorithms, then you get a better understanding of how the world works. So like creating an algorithm for shape detection can maybe help us understand how you would do something for like how AI works and the backings behind all of it, which will help us make like future better algorithms and like help us in general. But yeah, the factories and the gerrymandering and stuff like that, those are the main applications. Great, thank you.